Say timing. Evening, afternoon timing, then revision I will give. Punch you. This class, that class, art class, drawing class, all class you are doing.
I create 1 to 2.
You have.
And have education article.
That light is switch on. After that I'll talk.
Cricket coaching. Cricket coaching.
Cricket coaching.
Yes. So he is not available.
Wait. All type coaching we will start. Wait. Just wait. I will teach you what and all different type of classes are there. Now look here. Now look here. We'll start the class. Is matter around us pure first class? No talking, no joking. We are going in the characteristics. So characteristics of mixture. Last class we were talking about. We were trying to understand about mixtures. Okay. In the first content, what we have studied that about mixture. What we have studied that key mixture will be exactly. Tell me. Bah. They don't have. I told they don't have any boundaries. Means they don't have any boundaries. Super. That was seriously miraculous. No, I am going to ask you one question. That in matter chapter, is matter around us pure? Till here we have studied about elements. We studied about compounds also. We studied about different features. Now we are going to talk about the characteristics. In the characteristics section of mixture, characteristics of mixture contain more than one substance and show the following characteristics. They are consisting of what? More than one substance. Mixture, Unnati, good evening beta. They are exactly consisting of more than one substance. Understood? So in mixture, the constituent may be present in any proportion. This is exactly one of the most important part. Bhavya, good evening beta. The constituents can be present in any proportion. The constituents can be present in any proportion. That's one of the qualities of mixture. Understood not? So that means what? It is not like there is a fixed proportion. In compound, the proportions were fixed, but in mixture, the proportions are not fixed. Okay. Next is when we talk about mixture show the properties of all constituent present therein. For example, a mixture containing sugar and salt will be salty, sweet. Understood? So it will be consisting of what beta? Salty and sweet. Now next one, mixtures are heterogeneous. Mixtures are what? Heterogeneous. Understood? So it is not homogeneous, means its composition is not same throughout. It is heterogeneous. Understood? Next part is the component of a mixture can be separated by simple physical method. Yes or no? So if accidentally some mixtures will be, some substance will be added into other one, we can be able to separate it out. Understood? So what are the four characteristics we have studied about mixture? The first characteristics what we have exactly studied it, the constituents can be present in any proportion, and next is they are present therein. For example, second part what we have studied is sugar and salt will be present in any proportion. Understood or not? And they can be separated out. They can be separated out, and since they can be separated out, they will be called as what beta? Heterogeneous, and they will be exactly, you can be able to differentiate it out. Okay, means by seeing itself you can say salt is added to this part, means you can say that okay, it is a combination of different type of matters present. The substances are present in a combo phase here. I hope you might have understood this one. So now we will go for the next one. So this one file is over, we have studied about. So hello beta, hello Tanisha. So this part we have finished. Now we are going to go for the next one. So next part, when we are going to go, let's check this one out. So now we are going to differentiate about compound and mixture. Get ready for it, beta. So if somebody will be asking you what is the difference between the compound and mixture, what answer you are going to give? So what and all answers you are going to give? Come on, Bhavya, say. So if somebody will ask you about, so first thing is, in a compound, two or more elements unite chemically. Correct, na? So two or more elements are uniting chemically. They are exactly called as what beta? compound. But in mixture, two or more elements or compounds are mixed such that they do not combine chemically. So one is having chemical, one is not having chemical. Which one is having chemical? Chemical combination, where it is uniting chemically. Where it is uniting chemically? It is uniting chemically for compounds, but for mixture there is no chemical combination. Just two or more substances are added together. No new substance formed, and no new substance are formed, and a new substance are formed. Absolutely correct. So if somebody will be asking you in which new substance is formed, when a compound you are making, in which new substance are formed, then your answer will be कि when you are making a compound, the new substance will be formed, but mixture, no new substance. Good evening, Yuva. Good evening, beta. So no new substances are formed in a mixture. Understood? Mixture do not have a definite structure. Mixture do not have a definite structure. But when we talk about compound, so compound have a definite structure. So what are the different points we must be checking here? The different points what we are checking here is, the first part is exactly compound and mixture. So compound is having nature. In compound, two or more elements are uniting chemically, and here it is exactly compounds are mixed but they do not combine chemically. Here there is a definite structure, here there is no definite structure. What about composition? In case a compound, the constituents are present in fixed ratio. Understood? So that's the most important part. They are present in a fixed ratio. But when we will be seeing here, they do not have a fixed ratio. So when somebody will be asking you, are they having a fixed ratio? The answer is no. They don't have a fixed ratio. Their ratio is variable. Understood? Next point is, the properties of compound are entirely different and properties of its constituent. That is a big answer I am going to give you for a compound. Listen, you know that hydrogen is a gas and oxygen is a gas, correct now? So hydrogen and oxygen both are gases. But when hydrogen and oxygen both are combining together, they are making water molecule, correct now? Water is a liquid. So that means what? They are made with two gases and resultant is coming as a liquid. Are you understanding? That's the most important difference. Are you getting it? That's the most important difference. That means we learned a very important point here. Means a point which is very important and to be noted, that when you are making a compound, beta, the elements which is making a compound is different from that of the compound. Got it? So their composition, their content will be different. Absolutely correct, Yuva. Now we will go for the next one. The constituent of a mixture retain their individual physical and chemical properties. Like beta, if I will be adding salt in soil, if I am going to add salt in soil, salt property will be lost or soil property will be lost? No. Salt will be salt only, soil will be soil only. That means their properties retains the same. There is no change in that. Understood? There is no change in that. So since there is no change in the content, we assume that we say that the property retains the same. Got it? Now we will be going for the next one. Separation of constituent. The constituent of a compound cannot be separated by physical means. Can it be separated by physical means? No, it will not be separated by physical means. But here we can do the separation by physical means itself. Understood not? Like if I am going to accidentally add salt in soil, understood not? I need to add water in it. Got it? And then I have to filter it. The soil will get filtered. Now the water is having salt. If the water will be evaporated, we will get the salt back. Understood? So that means what? The constituent can be separated. But here once you are mixing it, once it is exactly combined, chemically combined, separation is not possible. Understood? Separation is difficult. We can separate it out, but separation is exactly not done by physical means. Understood? So here physically you can separate. Understood? Here physically you cannot separate. Only chemical separation is possible. Here physical separation is possible. Understood? Next is energy change. So yes, absolutely a very important point to remember. Yeah, Bhavya, understood beta? A very, very important point to remember that whenever any chemical reaction takes place, the reaction will be associated with either taking of energy or giving of energy. Are you understanding? Either taking of energy or giving of energy. Understood? So either intake of energy or giving. So that's energy exchange is exactly one of the properties of compound. But here, when you will be seeing mixture, in mixture there is no exchange of energy. So if salt and sugar added, they both are actually separated now. So there is no chemical reaction between them. See, compound is having a chemical reaction, but mixture is not having a chemical reaction. So I'm going to ask everyone one by one, say the first two characteristics of compound. Amrish, without seeing, say the properties. And online children, please kindly start saying the properties of compound. Come on, go for it, please. They have? They have a definite? The compounds have a definite shape. Good. Which is not having a definite shape? Which can be separated physically? Which cannot be separated physically? Good evening, Shanvi. Good evening, beta. The compounds cannot be separated physically. Absolutely. Another important point. Very good, Tanisha. A new substance formed and no new substance formed. Huh? Very good. Next point. Energy. In which one energy is released? Come on, children, online children. Just check your live set is open. So compound. Very good. So where energy release is not there? Very good. So that means mixture energy release is not there. I asked you another thing which is having a definite shape. Sanvi asked beta. She is having a doubt. Say ask. Ask Sanvi. Shanvi asked doubt. Okay. So now look at till she is typing the doubt, we will go for the next part. So types of mixture, depending upon the nature component that forms mixture, we have different type of mixture. First type of mixture is considered as homogeneous mixture, and another mixture is considered as heterogeneous mixture. So now we are going to understand what is the difference between homogeneous mixture and heterogeneous mixture. So a mixture is said to be homogeneous if the different constituent or substance present in it exist in one single phase. They are existing in one single phase. Understood? Without any visible boundaries. That's a very, very important point to remember. Okay, Shanvi. Auntie, can you just explain compound once more? See, compounds are made with elements in a fixed proportion by weight. So their constituents will be fixed. So if I'm talking about hydrogen molecule, two atoms of hydrogen will always combine with one atom of oxygen. So when two atoms of hydrogen are combining with one atom of oxygen, that means the atoms will be fixed. And that's what in the previous section I have explained you. Okay. Can you please check the previous videos, because there I have explained very nicely about compound. In that compound, beta, if somebody will ask you about glucose, so you know that glucose is having a chemical formula of C6H12 and O6. That means what? 6 carbon atoms will combine with 12 hydrogen atoms and 6 oxygen atoms. So when they will be combining together, beta, what they are going to make? They are going to make compound, and that compound is what, beta? Glucose. Understood? So glucose and complex sugars, their chemical constituents are both different. Though they both are carbohydrate, but they are exactly having different chemical formulas. The different type of carbohydrates are there. Starch is there, cellulose is there, maltose is there, sucrose is there, fructose is there, galactose is there. So different lactose is there. So different type of carbohydrates are there, and all the constituent formulas for the carbohydrates are different. Understood? So many carbohydrates. I talked about maltose, sucrose, what you call galactose. So they are different type of carbohydrates. I hope you might have understood, Shanvi. So whichever chemical formula is fixed is called as compound. So if somebody will ask you, I have given the example of hydrogen peroxide and hydrogen dioxide. Means hydrogen dioxide, H2O is there. So that is water molecule. Okay. So peroxide is H2O2. So that time when I have discussed, I have explained both are having hydrogen and oxygen. Both are having hydrogen and oxygen, but one is taking what, beta? One is taking, see, listen, one is taking what? One is taking 2 hydrogen atom and 1 oxygen. One is taking 2 hydrogen atom and 2 oxygen atoms. And constituent wise, they both are different. Understood? But you need to understand one simple thing, that when you are making mixture, remember this part, when you are making mixture, the mixture will be adding with many substances and you can see clear cut boundaries. But in mixture also there are two different type of mixture. One mixture is homogeneous, another mixture is heterogeneous. Now we are going to learn about homogeneous mixture. A mixture is said to be homogeneous if the different constituents or substance present in it exist in one single phase. Understood? So whatever substances are present in it, they will be consisting of one single, they will be present in only one single phase. Then it will be considered as what, beta? Homogeneous. Now we are going to see in homogeneous mixture, the constituent particles cannot be identified or seen without the help of powerful microscope. So beta, very good. Yuva has given one answer. It has uniform composition throughout. Homogeneous, it has not uniform composition throughout. Very good. So the one which is not having uniform composition throughout is called as heterogeneous. Very good, Yuva. Sir, today how was maths exam? I asked from here. Today, how was maths exam? Today, how was maths exam? Nice. Question paper, who will see? Show me. Forgotten. What a nice English. Oh, Yuvashri is the only one sincere child here. Ask Yuvashri with so much. Thank you. Okay, so now look at it. All solutions such as solution of common salt, copper sulfate, sugar, etc. are example of homogeneous. So if I have to see that anything mixed in one solution, I need to exactly, solution is made with solute and solvent. For homogeneous, what is exactly important point is I cannot see the boundaries. I cannot see the boundaries. What I cannot see is I cannot see the boundaries. Understood? So our homogeneous solid solutions of metals. So we will be seeing that alloy formation is also a homogeneous. Last class itself I have told now, alloys are not compound. Alloys are mixture. Alloys are what? Mixture. What type of mixture alloys are? What type of mixture alloys are? Alloys are homogeneous mixtures. Alloys are homogeneous mixtures. Understood? Similarly, alloys such as brass, bronze are homogeneous solid solutions of metals. Understood? Now, Amrish, he is writing something in his hand. Tell him he is not mental. How many times I have to say him? One time, two time, it is okay. Every time I am saying him, sir, you are human only. Look here. Very nice, super, very good. So matter exactly when we are talking about mixture, mixture is of how many types? What are they? When we talk about homogeneous, boundaries can be seen. If I want to know what in all is added in that, what I have to use? Microscope. Very powerful microscope. So examples, sugar solution, salt solution. Understood? Copper sulfate means we have to see, then only we will be. Exactly, absolutely correct, beta. So now where is today Arunisha? So all solutions such as solutions of common salt, copper sulfate, sugar are examples of homogeneous mixture. Similarly, alloys such as brass, bronze are homogeneous solid solutions of metals. I hope till here it is okay. Now we'll go for the next point, please. So classification of homogeneous mixture. So now we are going to see the classifications of homogeneous mixtures. So now let's talk about the classifications, beta. Yes, lemanoid also you can be considered in that only. So homogeneous can be further classified as follows. Solid mixture. What is that? Solid mixture. So in solid mixture, how we can say bronze, brass, all the alloys are examples of solid mixture. Solid means ki one element is added in with another element in the solid form. Understood or not? And they'll make a solid. So two solid combined together to give another solid. That's exactly called as. So this is exactly in homogeneous mixture. You know now alloy formation. Alloy means what? Brass and bronze we have learned about now. So they were alloys. Homogeneous alloys or heterogeneous? Homogeneous, because you cannot see the difference. Means brass is made, bronze is made, understood, steel is made. So they are exactly, you cannot be able to say that these elements are exactly making it. Correct now? These elements are exactly making it. You cannot see and say that these elements are present inside it.
Solid side make a solid mixture.
Mm.
But what makes the solid and liquid mixture?
That is exactly we are going to study. Solid liquid mixture we are going to talk, means it's very easy. It is exactly salt solution, sugar solution, lemanoid. They are solid and liquid. Correct now? See, solid is salt, liquid is water. And you know that where the solids are residing when you are mixing solid in liquid. Actually, solutes are less in number. Understood? The solutes are what? Less in number. So when we are talking about solute, like sugar, okay, just take for it, sugar. So when you are taking sugar, the sugar will disappear, the sugar will come in between the space of the water molecule. They will be present in water. Once you are adding sugar in water, sugar will not go anywhere. Sugar will be present in water. Understood? So that means what? They will occupy the space between the water molecules. They will occupy which space? The space between the water molecules. I hope you might have understood. They are occupying the space between the water molecule. Tincture solutions, yes, only. Understood? So that is solid and liquid. Now aqueous solution, salt, sugar, they are examples of solid liquid mixture. Solid liquid, what type of mixture? Homogeneous mixture. Solid solid example is alloy. Remember, solid solid example is alloy. Name of any two alloys? Bronze and brass. Name of any two alloys? Bronze and brass. Solid liquid, when we are talking about, what are the two? Sugar and salt. Sugar and water. Sugar and water. Salt and water. Lemanoid. Understood not? Where color will not be changing. Understood? So color will be changing also, means we have to check. Solution of iodine also is there. That is carbon tetrachloride also is exactly solution of iodine in carbon tetrachloride. Understood? So they are exactly certain example. Tincture solution. Okay. Now we are going to go for liquid mixture. So this type of mixtures are rectified spirit, like gasoline and alcohol mixture, mixture of toluene and benzene. So these make two different type of two different type of solutions. One solvent and one solute will be there. But when you will be mixing it, you will not be able to say that which one has mixed in which one. Understood or not? So only they are considered as what beta? Homogeneous mixture. Okay. Now we are going to talk about heterogeneous mixture. So for homogeneous mixture, solid, 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 liquid, liquid, liquid we have seen. How many we have seen? Say solid, 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 liquid, liquid, liquid. Again say solid, solid. Understood? Now we are going to talk about heterogeneous. Now in heterogeneous, it is exactly does not have uniform composition and you can be able to see them because there will be visible boundaries. What will be there? Visible boundaries. Understood? So there will be visible boundaries of separation between the constituents. In a heterogeneous mixture, these can be easily seen. Sometimes without with what you call, sometimes we can be able to differentiate it by just mere looking only. We can be able to differentiate it. Understood? So that's one of the most important point. Let's go for the next one. A mixture of sand and salt, iron powder and sulfur powder, soil are examples of heterogeneous mixtures. Now let's see some of the part of heterogeneous. Homogeneous, solid, solid. Homogeneous mixture, solid, solid. Very good. Solid, liquid. Sugar and water. Liquid, liquid. Ice water. Ice is liquid. Water is liquid. Mental activity started, na? All mental activity started. Super. Nice. Again say. Allah, I am talking about liquid, liquid, and here I am getting mental answers. Lamunoid in water. Ink in water, Yuvashri is telling. Just now we talked about iodine solution and iodine and carbon tetrachloride. They are two different type of chemicals mixing together. Forget about it. But they are not chemically mixing, they are physically mixing. Understood? And you will not be able to see the boundaries. Very nice. Super answer. Super, super. So now look here, beta. We'll talk about heterogeneous mixture. In heterogeneous mixture, milk also she is telling.
Milk in water.
Milk in water. Yeah, you become a milkman. That's a nice milk in water. Anything else left? Milk in water. No, no. Some good answers are coming for genius fellows. So I'm ready to listen that. Come on, say.
Milk in water.
Drink in water.
Water.
Milk in water came as liquid. So correct only na, you will not be able to know that milk is water is have present in milk. After that he is saying water in water.
Yeah, this is there.
What you said that time? Water in water.
You
Oh,
want to drink water.
he is telling you want to drink water.
We want to drink.
Oh, you said you want to drink water or he want to drink water
We both
or
want to
I
drink
should
water.
drink water.
We both want to drink water.
You both only drink water.
Want to drink water.
You both only want to drink water.
Ah, yes.
You both only want to drink
Now
water.
we want to drink water.
Now you want to drink water. Will you rectify properly? Then I will give you permission. See, this is
I want to drink water. Can you go?
I want to drink water. Hey, one by one. Monkey. See, how many times I want to drink water. I only drink water. I want to only drink water. Different type of constituents are there present in water. Monkeys, come fast. 1 minute. I hope so you'll return in 1 minute. Huh? 5 minutes. Okay. So now look here, beta. We are going to talk about classification of heterogeneous mixture. So now look here. When we talk about classification of heterogeneous mixture, first we are going to talk about solid gas mixture. Okay. So first solid and gas. Means solid will be added with gas. So that is considered as what, beta? Solid gas mixture. It is exactly considered as what? Solid gas mixture. Now check this one out. In solid gas mixture, we are going to first talk about smoke. So now smoke means solid particles of soot suspended in air. So you might be seeing that given fire will be there, some of the ashes, some of that contents will be gases contents are coming out. Understood? So that part you need to understand that smoke means the solid particles of soot that is suspended in air. You might be seeing that whenever fire will be there, you are burning wood, that time some small particles will be exactly getting suspended in air. Understood? So that's called as solid gas mixture. So smoke is solid gas mixture. Smoke is what? Solid gas mixture. Okay?
We can say 99 dollars. Or yes, mister.
Huh? What do you want to say? Naphthalene balls are undergoing sublimation. They are undergoing sublimation. They are not solid gas mixture. Understood? They are getting directly converted. Hey, huh? Sam, sit down. I'll teach sublimation. So now look here, beta. When somebody will talk to you about sublimation, just understand that even any substance like naphthalene balls are there, they are directly getting converted from solid to gas without getting converted into liquid. They are called as sublimation. Understood? So gases to solid, solid to gas without undergoing the intermediate phase, then only it is considered as what, beta? Sublimation. I hope you might have understood sublimation and sublimate is there. So now look here, sublime, sublimate. So now look here, so solid gas mixture. So when we talk about solid gas mixture, we need to check which and all are solid gas mixture. Now first is smoke. In smoke, what you are seeing, soot suspended in air. So solid particles of soot is suspended in air. That is considered as what, beta? Smoke. Now we are going to talk about dust. So dust means fine sand particles will be suspended in air. Dust means fine sand particles. See, soot particle suspension is smoke. Sand particle suspension is soot particle suspension. is smoke. Sand particle suspension is dust. Understood? Solid mixture. So you please remember this one. Smoke will be shoot particles suspended in air. Sand particle suspension is dust. Sand particle suspension is dust. Okay. So now solid mixture. Gunpowder is solid mixture. A mixture of containing potassium nitrate and potassium nitrate, sulfur and charcoal. So potassium nitrate, sulfur, charcoal, all three mixed together will be making what? Gunpowder. Understood? Aye. Mixture of sulfur and iron filling also is there. Got it? So now we are going to understand next one, solid liquid mixture. First we studied solid gas. Solid gas example. Come on, online children, start answering. Solid gas. Video. I'm talking about mixture. I'm talking about mixture. This donkey is talking about sublimation. At least he is a little bit correct. This boy is totally wrong. That one you have to see. Your friend, fellow friend, from this end you do like this. Beat, both of you. Now look here. Now, solid mixture. I am also for. I will not ask any questions from you three idiots. Now look here. Gunpowder, potassium nitrate, sulfur, solid gunpowder. What and all are the constituent present in gunpowder? Bah, only charcoal. After that, potassium nitrate and dust, dust. Sand particles suspended in air. Smoke. Shoot. Shoot particles suspended in air. Shoot suspended in air. So see, yes. Now next one, when you talk about solid liquid mixture, for example, suspension of sulfur in water is solid liquid mixture. Next is liquid mixture. For example, benzene in water, that is immiscible liquid. That's called as liquid mixture. Nothing. I'm awarding you with like you are such a genius student. So now let's see homogeneous and heterogeneous. Let's have a glance. Gases in gases, air. Gas in liquid, aerated. Water gas in solid. Hydrogen in palladium. Liquid in liquid. Ethyl alcohol and water. Water and oil, heterogeneous. Next, liquid in solid. Mercury in amalgamated zinc. Solid in liquid. Sugar in water. Chalk in water. Solid in solid. Alloys like brass, bronze. Very good, super, very good, super. Nice answer. Now we are going to talk about solutions. Okay. Now if somebody will be asking you solution, like we will be discussing about homogeneous. Okay. So solution is made with solute and solvent. So in a solution, solute is exactly present in less amount and solvent is present in more amount. Understood or not? So solvent is more, solute is less, and then solution is made. Okay. So now look here. A homogeneous mixture of two or more substances is called a solution. Example, sugar and water. So this means that if we take out 1 ml sample of from different part of solution, it will have same degree of sweetness. That's the most important point, beta. You need to understand one very important point, that if we are taking some homogeneous mixture, okay, just like solution like sugar solution, so whenever you will take any sip of that sugar solution, the taste, the sweetness remains the same. That means the sugar is distributed uniformly in the water molecule. I understand. I understood. You understood or not? Understood. So now the same concentration means you need to understand that in the entire solution, the concentration remains the same. Got it? So if I will be taking 80 ml in that 20 ml solute, 80 ml of water, 20 ml of salt I am adding, 20, what do you call that? If I'm 20 ml of salt solution, I'm going to add 100, it is coming. Salt solution, I said. So 20 ml of salt solution, I am going to add that particular moment, the whatever solution, 80 ml and 20 ml salt solution, means salt added in.
But how ML will be coming for starting?
So only I told salt solution. Salt solution means salt added in water. Got it? So the concentration is 100 ml. I'm not talking about salt. I told salt solution. Okay. Salt solution means salt added in water. 20 ml of salt solution. That means what? This 20 ml of salt solution, when it will be added with 80 ml of salt solution, total how much coming? 100 ml. So it will be exactly nicely miscible, mixed with each other, and the composition, the concentration will be uniformly distributed in the entire solution. I hope you might have understood this one. That's what beta, the same degree of sweetness and saltiness will be there, the same concentration. It means all 1 ml sample of this solution will contain same number of sugar and water molecule. That's what it is, exactly example of uniform distribution. It is example of what beta? Uniform distribution. I hope you might have understood this one. So this is example of what distribution? Uniform distribution. So this is exactly example of what beta? Uniform distribution. So dust-free air is a homogeneous mixture of many gases. The main gases present in air are nitrogen and oxygen. So dust-free air means the air which is not having dust, smoke. That is exactly what? Yes, smoke is homogeneous. Smoke-free air is homogeneous. Dust-free air is homogeneous. Soham, good evening, beta. Huh? Soham. Now, beta, we are going to talk about solvent and solute. So already we know that solvent. We are going to talk about solvent. Let's talk about it. See, listen. Till now, what and all we have studied. Okay, who is having a definite proportion? Mixture or compound?
Compound. Compound.
I'm staying in Chennai, beta. Anupuram. Chennai, South. Compound. Very good. Alloys are? Which class, beta, you are in? Alloys are? First you tell me, alloys are heterogeneous or homogeneous? Homogeneous. Understood? Solid and solid. Alloys are homogeneous, solid and solid. Now beta, compounds we are going to see. We understood one thing, that right now we are in solution state, and we learned that solution is made with solute and solvent. Solute amount is less, solvent amount is more. Understood? So now here, check this one out. If somebody will be talking about solvent, let's learn the solvent part. Which class, beta? Where it is? So now the component of solution which dissolves the other component in itself is called as solvent. So what new property of solvent we learned about? Okay. Welcome, beta. Good evening. Now look here. Solvents are that part of solution which dissolves the solute in it. Understood? So water is considered as universal solid. Why? Sorry, water is considered as universal solvent. Why, beta? Because it has the capability to dissolve solutes in it. Solutes means it is not one type of solute. Many different type of solutes can be dissolved in water. So water is considered as what, beta? Water is considered as uniform solvent. What is water considered as? Uniform solvent. Very good. This is what I checked. It is not uniform, universal solvent. Caught, na? That is, you are not concentrating. Water is exactly. Very nice, Peter. Very nice. Did you understood this one? So water is universal solvent and it is dissolving solute inside it. It is dissolving solute inside it. There will be different type of solutes, beta. So solutes, when we are talking about, so we can say that salt is acting as a solute, sugar is acting as a solute. Many different type of solutes can be there. Understood or not? So now we will go for, yes, universal solvent, beta. So here some big monkey was there. I asked him, I just changed the statement, that monkey is telling yes, yes, yes. With that only I came to know that they are not listening. Can you bring your note here, please? So we will be talking about the next part. Check this one out. Next part. So solvent will be first part we have understood. A solvent is the larger component of a solution. Yes, if you talk about solute and solvent composition, the ratio of their, what you call, participation is the ratio. How much a solvent will be there, how much a solute will be there. Then we are coming to know that the solvent is always added in more amount in compared to that of solute. I hope you might have understood this one. Next is the solution of copper sulfate in water. Water is a solvent. So solution of copper sulfate in water. So similarly in paint, that what you call turpentine oil is the solvent. Understood? So whenever we talk about, we must be understanding one thing, that whenever we talk about a solution, the solution is made with solute and solvent. The solvent will dissolve solute in it. Who is dissolving whom? Solute will be dissolved in solvent. Solvent, what you call, proportion is more in compared to that of solute. Got it? Water is considered as universal solvent. Why? Because most of the things, most of the solute, it is dissolving in it. Understood? So most of the solute, water is dissolving in it. So water is considered as what, beta? Universal solvent. So water is considered as what? Universal solvent. I hope till here you might have understood, beta. Now we are going to talk about solute. So the component of solution which dissolve in solvent is called as solute. The one which is getting dissolved, is called as solute. So solute composition is may be different, but it has to what? It has to get added in solvent. Understood? So their ratios, the amount what a solute is added in a solution is always less. Understood? So next part is, usually solute is a smaller component of a solution. For example, the solution of common salt in water. Common salt is the solute. Similarly, in carbonated drinks like soda, water, carbon dioxide gas is the solute. Why, beta? Because carbon dioxide is added in less amount. Carbon dioxide is added in less amount in carbonated drinks. See, the fizziness of this type of drinks will come because of the presence of carbon dioxide. Understood? So you might have seen thumbs up or some different type of aerated milks will be there, where the moment you will open the lid, you will see some fizziness. This fizziness is because of this carbonic acid. Understood? The carbon that will be exactly mixed with water, they will be exactly making carbonic acid. The fizziness will come because of that only. Now saturated solution. Now first we are going to understand about saturated solution. Next, unsaturated solution and supersaturated solution. So there are three different type of solutions we are going to talk about: saturated, unsaturated and supersaturated solutions. So how many type solution we are going to talk about? Saturated, unsaturated and supersaturated solutions. Okay. Now first we are going to talk about saturated solution. So you need to understand that when a solution which at a given temperature, so here temperature is very much accountable. Please be very careful. This is a very important point, and from this section they're asking question. So I need to be very careful teaching in this section to you. Okay, beta? So here you need to understand. See, where we can playfully take out, I will not be saying you. But this part is very important. So understand. Beta, here temperature is one of the major factor. For you need to understand saturated solution, supersaturated solution and unsaturated solution. So you need to understand that one thing is very, very important is temperature. Temperature plays a very important role here. Now one example I'm going to tell you. With that example you try to understand better. Now I took one glass of water. I don't know any experiment. I'm not a scientist. I'm no one. Okay. I'm just a layman having no information about chemical world. Okay. So I took one glass of water. In that I started adding salt. Got it? I kept on adding salt. Now, after adding some amount of salt in water, after that again I am stirring it, again adding salt, again stirring it. So one stage will come when the water will not accept salt. Why? Because what and all space between water molecules were there, it has been occupied by the salt. Understood? So just the gaps between the water molecule start getting occupied by whom? It start getting occupied by salt. One stage will come when it will not at all accept it. Understood? So one stage will come when it will not at all accept. So till it is accepting, it is exactly called as unsaturated solution. Understood? But the stage, the critical stage, it will not dissolve it. That time it will called as saturated. Got it? Means if you will put more salt in that, the salt will be seen. It will not at all mix. You'll try your level best. At a particular temperature, it will not at all mix, like a room temperature. Understood? In room temperature, you kept on adding salt till sometime the salt got disappeared. One stage came when the salt is not at all disappearing. So at that particular moment, we can say that the disappearance has vanished. That means this solution is called as what? Saturated. So till it is not seen, till the salt is not seen, it is unsaturated. But once the salt will start seeing in a solution, means it is now saturated. Means it will not be dissolving any more salt particles in it. Till here it is clear? So that stage is called as saturated. Means it reached this critical stage. I won't take more salt because all the gaps between the water molecule is filled. Filled with what? Salt. Understood? So salt molecules has filled all the gaps. So that stage is called as saturated. Understood? So now we are going to study about it. A solution which at a given temperature dissolves as much as solute as it is capable of dissolving is said to be saturated solution. Unsaturated when the amount of solute contained in the solution is less than the saturation level. Understood? So once the saturation level is reached, we cannot expect more dissolving. Got it? But before saturation state, the things will keep on getting dissolved. The things will keep on getting dissolved. Understood? So now we are going to talk about super saturated solution. Now we are going to study about super saturated solution. So when someone will discuss about super saturated solution, a solution which contains more of solute than are required to make a saturated solution is called as supersaturated solution. So how can we attain supersaturated? Means a stage where I can dissolve more. How it is possible? We will give heat. What we will provide? Heat. You might have seen that the sugar syrup what they are making. When they are making some sugar syrup, the sugar syrup will not be like, it will be very sticky in touch now. If you will be seeing, even the salt will be more present, means it will be slippery in touch. Understood? When it will be there, beta? When you will start heating the solution, see what will happen, the water molecules will start dancing. Now, in that dancing, the molecules of the water will give some more free space. Understood? So, because now, see, it was still now silent. Water molecules will till now silent. The gaps were there layer by layer. Just imagine layer by layer is there, and in that all gaps will be there. All the gaps was filled by salt particles. Now it is saturated. But now I want more salt or sugar to be added. Understood? So what I did, I started heating it. The moment I started heating it, the gaps increased. Why? Because the salt, sugar part, the water molecules started having gap between them. Understood? The gap will between them, and they will start dancing up and down. So at that stage, when they will start dancing up and down, they will give more or they will provide more free space. What they will provide? More free space. When they will provide more free space, at that particular moment, more salt will get dissolved. Understood? So that stage is called as what, beta? Super saturated stage. Many of the candies and all you might be seeing that they will keep on adding them. Understood? That time it will be liquid, but when you will solidify, it will come as a solid sugar. Understood or not? So the chocolates, the sweet chocolates are made with. I hope everybody understood this one. Saturated, unsaturated and super saturated. Unsaturated means solute amount is less. Saturated means solute. Yes, and it is exactly, there is no free space in the solvent to occupy them. That's the stage of saturation. Super saturated means you have to, but that temperature will be low or more. More. So at that stage, the temperature will be more and more things can get dissolved in it. I hope children you might have understood this part na beta. So now we will go for the next part. Now please understand, on the basis of solvent, we are going to talk about aqueous solution and non-aqueous solution. So what is aqueous solution? Aqueous means water. Correct na? Aqua. Aqueous means water. The solution obtained by dissolving various substance in water are called aqueous solution. You are going. How many people will come? Because 2 students are also there. These 2 are there, no? They're 2 girls. 4. Yeah. 1 can accommodate, but 4 will be how it will be in backside. You asked to that, or if you will adjust somehow means okay. Yeah. So now look here, common salt dissolved in water. Now look here, beta, aqueous. The solution obtained by dissolving various substances in water are called as aqueous solutions. Understood? So now example, common salt dissolving in water, sugar dissolved in water. After that, acetic acid dissolved in water. So all of them, the solute is getting added in water. So when solute will be another anything, liquid or solid, or gas, but it will be exactly using what? Water as a solvent. That solutions are called as aqueous solution. What that solutions are called as? Aqueous solutions. Now we are going to understand about non-aqueous solution. The solution obtained by dissolving the substance in liquid other than water are called as non-aqueous solution. What they are called as? Non-aqueous solution. So their solvents are not water. We must check that one. The solvents are not water. Now let's check this one out, beta. The solution obtained by dissolving the substance in liquid other than water. Now let's see some example. Common non-aqueous solvent is alcohol, carbon disulfate, carbon tetrachloride, acetone, benzene, etc. So they will be exactly the solvent. They are what? Solvent. Like right now we have seen na, the iodine getting added in carbon tetrachloride. So what is solvent here? Carbon tetrachloride. Their carbon tetrachloride is solvent and iodine is acting as solute. Understood not? So that will be exactly non-aqueous solution. Now look here the examples. Iodine dissolved in carbon tetrachloride, sulfur dissolved in carbon tetrachloride, sulfur dissolved in carbon disulfate, sugar dissolved in alcohol. They are all using the solvent other than water. I hope you might have understood. They're all using solvent other than water. On the basis of physical state of solute and solvent. This we will do in the next class. Okay? We're keeping it till here, children. Bye, everyone. I hope you might have liked the class. Is it okay for you? How was the class you learned? Bye, everyone.